And part 2 of this question, definitely, okay, it is totally what we have expected, differentiation. We want to use differentiation to find the maximum value of v. Wait, before we differentiate, okay, I want to find dv dx and let it be equal to 0 because that will tell me what is the stationary point of v, okay? But before that, wait, let's expand this first, okay? It is going to make our process of differentiation way easier. We're expanding this 1 over 4x square root of 3, this, it is going to become a square minus away 4ax square root of 3, and this is going to give me a positive of 12x squared. Okay, then multiplying x in, it is going to be 1/4 square root of 3 a square x minus 4ax square root of 3 plus 12 x to the power of 3. Okay, and this is way simpler to differentiate. Okay, differentiating this with respect to x, I will get dv dx to be equal to 1 over 4 square root of 3 of a square minus 8ax square root of 3 plus 36x squared. And I'm going to let dv dx be equal to 0. Okay, so letting dv dx be equal to 0, it is going to be 1 over 4 square root of 3a squared minus 8ax square root of 3 plus 36x squared is equal to 0. With this, I can just multiply across. So what I will be getting is going to be 36x squared minus 8ax square root of 3 plus a squared is equal to 0. Okay, I need to solve for x because that is going to be the value that is going to cause v to be stationary. Okay, solving for x, let's use the quadratic formula. Okay, I can see that it is going to be a very tedious set of solutions that we are getting. Okay, so quadratic formula minus b, 8a square root of 3 plus or minus square root of b squared. So minus 8a square root of 3 squared minus 4ac. Okay, and this divided by 2a. So 2 times of 36. If I were to evaluate this square root of 3 plus or minus, evaluating this, I will be getting a 192 of a square minus 144 of a square divided by 72. This, it is going to be 8a square root of 3 plus or minus, this what I'm going to be getting is a 48. 48a squared divided by 72. It is going to be 8a square root of 3 plus or minus this 48. 48 is 16 times 3. So it is going to be 4a of square root 3 divided by 72. Okay, which means that x that I'm going to get is going to be 2 possible values. One is 1 over 6a square root of 3. The other one is 1 over 18a square root of 3. Okay, one of it is going to cause v to be the maximum. So I need to test. Okay, in fact, the question also asks us, okay, we need to prove that the value of v that we have gotten is a maximum value. Okay, let's use the second derivative to test. Okay, so I'm going to find d square v over dx squared. Okay, d square v over dx squared, differentiating this, it is 1 over 4 square root of 3, okay, a squared, it is going to disappear. What I'm going to be left with is a minus 8a square root of 3 plus 72x. Okay, so with this, I'm going to substitute each of these values in. Okay, whichever one that is less than 0 is going to provide for me the maximum possible v. So when x is, let's say, 1 over 6a square root of 3, okay, d square v over dx squared, this is equal to 1 over 4 square root of 3 minus 8a square root of 3 plus 72 of 1 over 6a square root of 3. With this, if you were to evaluate, it is going to be 1 over 4 square root of 3, 4a square root of 3. Okay, and this by itself is already positive. Okay, so I know this is going to give me a minimum v. Okay, it is not going to be what I want. I'm going to sub the other value. The other value is when I sub x to be equal to 1 over 18a square root of 3. Okay, substituting this value into d square v over dx square, okay, I'm going to be getting d square v over dx square to be 1 over 4 square root of 3 minus 8a square root of 3 plus 72 of this. Okay, this is okay, I'm really running out of space here. Okay, it is indeed a very long solution. It is 1 over 18a square root of 3 and close bracket. Okay, and this what we will be getting is 1 over 4 square root of 3 of minus 4a square root of 3, and this is less than 0. So for this, v is going to be a minimum. Okay, and for this, v is going to be a maximum. Okay, and maximum, this is what we want. Okay, so now we know what is the maximum v. It is just to substitute x is equal to 1 over 18a square root of 3 back into here. Okay, so let me do that here. The maximum possible value of v is going to be equal to 1 over 4 of x. X is equal to this 1 over 18 a square root of 3. Okay, this multiplied by square root of 3 of okay, I'm substituting it here. Okay, so multiply by a minus 2x, 2 multiplied by 1 over 18a square root of 3 times square root of 3 square. And this, if you were to evaluate, okay, this here, it is going to be 1 over 24 of a, and what we have here is going to be 2 over 3 of a square. So evaluating this, the maximum possible value of v is 1 over 54a to the power of 3.